Welcome to Vision Animated Study. Here, you can learn with visualization. Please, like and subscribe.
Introduction. Out of all the 5 sense organs, eye is the most important organ of our body. It is because of eyes that we are able to see and appreciate the amazing world around us. Our eyes makes us see the colors of the world. Objectives. At the end of this lesson, you'll be able to understand working of human eye, know defects of vision and their correction, understand the refraction of light through prism, understand the dispersion of white light by glass prism, know atmospheric refraction and its applications, know scattering and its applications, the human eye and its working. Our eyes makes us see the colors of the world. Human eye has a crystalline lens and it works like a camera. Various parts of eyes along with their functions are cornea. It is the transparent bulge on the front surface of eyeball. Light enters the eyes through cornea. Iris. It is a thin and circular diaphragm behind cornea which controls the size of the pupil. Pupil. It is a hole in the center of iris that appears black and controls the amount of light entering in the eyes by shrinking or expanding. Retina. It is a delicate membrane which acts as a screen. The eye lens forms a real and inverted image of the object on retina. Power of accommodation. Human eye lens has the ability of increasing or decreasing the focal length. It is known as the accommodation. Accommodation is achieved with the help of ciliary muscles. There is a limit up to which focal length of eye lens can be adjusted. Far point. The maximum distance up to which we can see a distant object clearly. To see a distant object clearly, ciliary muscles relax to make the eye lens thin. Near point. The least distance at which objects can be seen clearly without any strain. To see a nearby object clearly, ciliary muscles contract to make the eye lens thick. Defects of vision and their correction. Eye may lose its power of accommodation due to some refractive defects. There are 3 such defects. Myopia or nearsightedness. In this type of defect, a person is not able to see the far-off objects clearly. The image of the object is formed in front of retina. It is caused either due to elongation of eyeball or due to excessive curvature of eye lens. To correct this defect, concave lens is used because its diverging power, so that it directs the light rays on the retina for image formation. Hypermetropia and its correction. In this type of defect, a person cannot see nearby objects clearly. In this case, focusing of light rays by eye lens takes place behind retina. It is caused either due to increase in focal length of eye lens or due to decrease in size of eyeball. To correct this defect, a convex lens can be used which converges the light rays on retina and hence image formation takes place and the person can see the nearby object clearly. Presbyopia and its correction. In this type of defect, a person is neither able to see a distant object nor a nearby object clearly. This defect is a result of weakening of ciliary muscles and decrease in flexibility of eye lens with age. To correct this defect, person has to wear a bifocal lens having concave lens in upper part and convex lens in lower part. Refraction of light through a prism. Refraction is the bending of light as it travels from one medium to other. In this section, we shall discuss the phenomenon of refraction by a glass prism. A prism is a solid figure having 2 triangular bases and 3 rectangular surfaces. Angle between each surface is known as the angle of prism. A ray of monochromatic light is made to incident on a glass prism, bends towards the normal at the air-glass interface, then travels straight and bends away from the normal at glass-air interface. The emergent ray and the incident ray are at an angle known as angle of deviation. Dispersion of white light by glass prism. Now we shall discuss what will happen if we incident white light on the glass prism. As white light is made to fall on a glass prism, it gets split into 7 colors: violet, indigo, blue, green, yellow, orange, red. This phenomenon is known as dispersion of white light. Reason of dispersion. White light consists of 7 different frequencies which correspond to a different color. Angle of deviation for each color is different, because of which each color bends at a different angle, and we see a band of colors known as vignette. Recombination and rainbow. Recombination. Isaac Newton observed that if he keeps 2 glass prisms parallel to each other such that one is inverted with respect to other, then white light entering into one prism gets split into 7 colors, which when fall on other prism recombine to give white light again. This is termed as recombination. We all love to see the lovely view of rainbow after the rains. It is a natural phenomenon which occurs as a result of dispersion. A rainbow is always seen opposite to the sun in the sky. During rain, water drops act as prisms for the sunlight. Water drops refract, disperse, and then internally reflect the sunlight to give the rainbow. Atmospheric refraction and its applications. Our atmosphere is not uniformly dense at any local place. Depending on the local condition, it may have hot and cool air near the ground. Hot air is lighter than cooler air and hence has lesser refractive index than cooler air. Due to this starlight or sunlight entering, the atmosphere undergoes refraction. This is known as atmospheric refraction. As light coming from stars passes through the atmosphere towards the normal, and the apparent position of star is seen above the real position of star. Also, the starlight keeps on wavering because of dynamic nature of atmosphere, and hence stars appear to be twinkling. For us, sunrise occurs when sun is above the horizon. When sun is below horizon, sunlight entering the atmosphere gets refracted due to difference in density of the atmospheric layers. Because of this, sun is seen above the horizon, and we see the sunrise 2 minutes before sun actually reaches horizon. Similarly, sun sets for us 2 minutes late because of atmospheric refraction only. Scattering of light and its applications. As light passes through the atmosphere, gets spread by dust particles or other air molecules. This is termed as scattering of light. The color of light scattered depends on the size of the scattering particle. Tyndall effect. When a light is made to fall on a colloidal solution, it gets scattered by the colloidal particles, and hence the path of light becomes visible. This is termed as Tyndall effect. Like in a dark room, when a hole is made and light is allowed to pass through it, then we are clearly able to see the path of light as well as the dust particles which otherwise are not seen in the air. Following are the examples of scattering of light. Color of sky. As the sunlight passes through the atmosphere, the blue light gets scattered more than any other color, as the wavelength of blue color is just optimum for getting scattered by the finer particles of atmosphere. So blue color reaches us and we see sky blue. That means if Earth has no atmosphere, then the sky will appear black. Color of sun during sunrise and sunset. At sunrise or sunset, sunlight travels the maximum distance. So the blue color having shorter wavelength gets scattered and only red colors reaches us, being longest wavelength. So the sun appears red at sunrise and sunset. Did you know? A human being has a horizontal field of view of about 150 degree with one eye and of about 180 degree with 2 eyes. The twinkling of a star is due to atmospheric refraction of starlight. The sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of atmospheric refraction. The pupil can increase its size also under the effect of strong emotions. The blue-eyed ones see better than the brown-eyed ones. The iris color has no link with the visual sharpness. The human eye sees basically 3 colors: red, green, and blue. These are basic colors. The white is a combination of the 3. The black is their lack. Yellow, purple, or mauve form through the combination of two basic colors. These are called secondary colors. Dogs can't see the difference between the colors red and green. The average person blinks 12 times per minute, about 10,000 blinks in an average day. The eye is the only part of the human body that can function at 100% ability at any moment, day or night, without rest. It is impossible to sneeze with your eyes open. The space between your eyebrows is called the glabella. Under the right conditions, the human eye can see the light of a candle at a distance of 14 miles. People generally read 25% slower from a computer screen than from paper. Summary. Let us summarize what we have learned. Human eye has a crystalline lens and it works like a camera. Various parts of eye are pupil, cornea, iris, crystalline lens, and retina. Human eye lens has the ability of increasing or decreasing the focal length. It is known as the accommodation. Cataract is an eye disease in which eye lens loses its transparency, due to which partial or total loss of vision may take place. It can be treated by a surgery. A prism is a solid figure having two triangular bases and three rectangular surfaces. Angle between each surface is known as the angle of prism. As white light is made to fall on a glass prism, it gets split into 7 colors: violet, indigo, blue, green, yellow, orange, red. This phenomenon is known as dispersion of white light. Recombination is the phenomenon which is opposite to dispersion. Refraction of light as it passes through different layers of atmosphere is termed as atmospheric refraction. Tyndall effect. When a light is made to fall on a colloidal solution, it gets scattered by the colloidal particles and hence the path of light becomes visible. Scattering. As light passes through the atmosphere, gets spread by dust particles or other air molecules.
Thank you for watching. Please like, share and subscribe.